In the two earlier videos, we considered how to collect data on a single categorical variable, summarize it using a frequency distribution, and to picture the insights using a pie or bar plot. Then we also considered the case of two categorical variables, and we looked at how to summarize the data values using a contingency table and how to picture the insights relating to the association or absence thereof of between two categorical variables. In this video, we want to move on to numerical variables. So let's say you've collected data on the ages of students in a class. How would you analyze or summarize or condense that data into a human digestible form? Well, that will depend on whether we should use a grouped or an ungrouped frequency distribution table. So to start with, as far as a numerical variable is concerned, we summarize a numerical variable using either a grouped or ungrouped frequency table. Here is an example of an instance where we are going to consider how to use or when to use an ungrouped frequency distribution. I have been given the following data and I'm required to develop a frequency distribution. Should I use a grouped one or an ungrouped one? The only consideration I need to make here is to consider the range of values in this data set. If you look closely, the least value is 0 and the highest value is 10. Well, if I were to write out the individual values 0, 1, 2, up to 10, that would not look too long. So in this case, I'll rather keep each number in its own individual group. This leads us to an ungrouped frequency distribution, which indicates that each number is not grouped with other numbers. Rather, each number remains in its own group. So I'm simply going to follow that up with the frequency, or how many times did I see 0 pop up here? That is just 1. What about 2? It only occurs 1. 3, 3 times. 4, 4 times. 5, 5 times. And then 6 is 7 times. And 7 is 5 times. 8 is 3 times. And 10 is 1 time. And I have a total of 30 numbers. Similar to what we did earlier, you have the relative frequencies. So this will be 1 out of 30, 1 out of 30, 3 out of 30, 4 out of 30, 5 out of 30, 7 out of 30, 5 out of 30, 3 out of 30, 1 out of 30. In other words, we're considering the weight of each frequency relative to the total. Then we introduce the concept of cumulative relative frequencies. This only applies when the data values have an inherent ordering structure. In this case, the number 2 comes after what? Comes after 0 and comes before 3 in the ordering structure. So in this case, to get the first cumulative relative frequency, it would match the relative frequency in the first row. In the second row, 1 over 30 plus 1 over 30, you have 2 over 30. Then 2 over 30 plus 3 over 30, we have 5 over 30. 5 plus 4, we have 9 over 30. 9 plus 5, 14 over 30. 14 plus 7, 21 over 30. 21 plus 5, 26 over 30. 26 plus 3, 29 over 30. And lastly, 29 over 30 plus 1, that gives us 30 over 30, which is equal to 1. Of what use is this column of cumulative relative frequency? Let us consider that quickly. You see, if I asked that in the raw data provided initially, that how many data values are equal to 5? What is the relative frequency? What is the percentage? I would say that would be 5 out of 30 multiplied by 100%, or the ratio or the proportion is 5 out of 30. How many values are 8? Well, I'll say 3 out of 30. However, if I flip the question and I tweak it up a little bit and I said, how many numbers are equal to 8 or lesser than 8? Well, that would be the addition of all of these numbers. And no surprise that this will be equal to this number, which is 29 over 30. So, how many numbers are equal to 4 or below? Well, that will be equal to 9 over 30. That is a question that cumulative relative frequencies answer. Let us see another example of a grouped frequency distribution this time and why that would be useful. Well, in this example, a shipping company recently selected a random sample of 36 airplane weight slips for crates shipped from an automobile parts supplier, and the weights, measured in pounds, have been provided here. What we notice is that if we wanted to analyze this data set, our consideration was, should I use a grouped or an ungrouped frequency distribution? The first step is to sort the data set from the smallest, the data values from the smallest to the largest value. You might agree with me that trying to write 78, 79, up to 99 individually in an ungrouped format, that would prove to be quite tedious. So we're not going to do that. So otherwise, we're going to use a grouped frequency distribution. In what sense? We're going to use a grouped frequency, relative frequency, and cumulative relative frequency distribution, which I will show you here. And how do you proceed to do that? You see, my goal is to divide all of these numbers into 5 groups or classes of equal widths. So mentally, I am saying in traveling from 78 to 99, I'd like to divide this into 5 equal groups of equal widths. And to do that, I'm going to start from the smallest number, which is 78. But the gap between 78 and 99, I'd like to divide it into 5 equal parts. So how large or how wide is that gap? I'm going to determine what we call the class width. The class width then will be how large should each class be? That will be a function of saying the difference or the gap between 99 and 78 divided by 5 class into 5 classes. That'll give about 4.2. Well, I would like to round that up to the nearest whole number, which is 5. So that means I'm going to let each class have a class width of 5. In what sense? Well, this is 78, 79, 80, 81, 82. 5 numbers. So that means that the first class will go from 78 to 82, and the next one will pick up from 83 to 87, 88 to 92, 93 to 97, 93 to 97, and then lastly we have 98 to 102. You might notice that even though 102 is not a number here, but the goal is to ensure that the last class covers is such that a particular number fits into that group of numbers. So then next I'm going to count the frequency. How many numbers in this data set are in this group, 78 to 82? That would be all of what I am highlighting here, in which case you will count that to be 8. Then the next one is 10. Oops, let's see. The next one is 10. The next one is 6, 9, and 3 for a total of 36 counts. Relative frequency, we're going to look at 8 out of 36. And then next 10 out of 36. The next is 6 out of 36. 9 out of 36, and finally 3 out of 36. For the cumulative relative frequency, the first rows will match. Then subsequently, 8 plus 10, 18 out of 36, 18 plus 6, 24 out of 36, 24 plus 9, 33 out of 36, 33 plus 3, 33, 6 out of 36, same as 1. And we can begin to extract what? Insights from that data and answer business questions. For example, what percentage of sampled crates have weights greater than 97 pounds? Greater than 97 pounds. We're interested in the percentage. That would be, we can quickly go to this. And that tells us that about 3 out of 36 multiplied by 100%, which represents 8.33% of the sampled crates weigh greater than 97 pounds.